Welcome to this comprehensive educational overview of programmable logic controllers, where we will demystify PLC technology through the lens of the legacy Télémécanique TSX series. Historically, modifying industrial machinery required the physical rewiring of hundreds of mechanical relays. Today, we will deconstruct how these physical components are translated into software logic to understand how modern industrial control works from the outside in. Before digital controllers, logic was dictated by physical paths of electricity. For example, in a standard motor starter, the start and stop buttons are wired directly in sequence to a mechanical contactor, and any change to this logic requires physically cutting and moving copper wire. The PLC revolutionizes this by replacing physical wiring with a digital program that mimics the electrical path, where physical buttons become digital input contacts and contactors become digital output command coils, drastically saving space and enabling instant modifications. The TSX 17-20 Micro PLC serves as a classic hardware translator, typically accepting 110 or 240 volts AC power, utilizing terminals 0 to 23 as inputs to monitor physical switches, and terminals 0 to 11 as outputs to provide relay outputs for loads like contactors and indicator lights. To handle software expansion, these early architectures featured a prominent cartouche slot, which housed physical language cartridges like PL7-2, allowing engineers to easily swap memory limits or languages on the factory floor without replacing the entire PLC unit. As technology progressed, units like the TSX Nano scaled digital control down into a highly compact, standalone footprint that provides its own 24 volts DC output for sensors and manages 9 inputs and 7 outputs for direct wiring to actuators, lamps, and sirens. Looking under the hood, the internal brain of the PLC operates on a continuous scan cycle where the input interface translates physical signals into binary data, the microprocessor evaluates this data against stored ladder logic, and the output interface translates those decisions back into physical commands for pre-actuators. This internal architecture is powered by a microprocessor executing millions of instructions per second and a memory unit housing both the operating system and the user's ladder logic, all connected by a high-speed internal bus governed by the precise timing of an internal clock. Ultimately, the shift from the TSX series to modern systems represents a paradigm shift where software flexibility replaces physical complexity, ensuring that industrial automation remains infinitely adaptable, scalable, and relentlessly efficient. Ready to move beyond the physical constraints of hardwired control? At SVIZONA Industrial Solutions, we specialize in helping you navigate the fundamental paradigm shift from complex physical wiring to flexible software logic. Follow the SVIZONA Industrial Solutions LinkedIn page to stay updated on how we demystify internal processing architectures and help you build automation systems that are infinitely adaptable, infinitely scalable, and relentlessly efficient. Join our community to explore more deep dives into the technology that drives modern industrial control, from the outside in.